Hello, I'm Suthaggar Elango. The topic that we are going to present today is electric dipole. Without further ado, let's hop into the topic. When I say electric dipole, the important point that should come to your mind is two charges that has the same magnitude but has the opposite sign, which is separated by a small distance. So now let's move on to the electric dipole diagram. This is nothing but the electric field line. Okay, now we have two charges with same magnitude but opposite sign. One is negative, another one is positive, and it is separated by a distance d. Each charge has a force. The force of the positive charge is in the same direction of the electric field, whereas the negative charge has a force which is in the opposite direction of the electric field. Now, what is electric dipole moment?
Electric dipole moment is denoted by P is equals to QD, whereby Q is the charge and D is the distance between the charge. So now, what is electric dipole moment? We have electric dipole diagram here, and to make it simple, you guys can imagine electric dipole moment as the size of electric dipole. Electric dipole moment is a vector quantity and it is measured by using coulometer. So, electric dipole potential. I'm going to give you a short introduction about electric dipole potential. The electric potential surrounding a dipole, or known as the net electric potential, is actually the sum of potential associated with each charge, which means the potential associated with the positive and the negative charge.
Good morning to everyone. My part is to explain about the simple example question for this topic. So the question A, Dr. Wong is a chemistry lecturer that explained that the water molecule H2O is formed due to the differences in electronegativity. Oxygen has a partial negative charge and hydrogen has a partial positive charge. When atoms in a molecule share electrons unequally, they create what is called a dipole moment. The question asks us to help Dr. Wong to describe electric dipoles, distinguish between electric dipoles and electric dipole moments, and the third one is provide an example of application of electric dipoles. So this is question B. Total marks of this question A and B is 5 marks. Let us proceed to the question A first. Solution for question A. Describe electric dipoles. The answer is electric dipole consists of two equal charges separated by a distance d. And number 2 is distinguish between electric dipole and electric dipole moments. The answer is electric dipole is just the separation of two equal and opposite charges separate a small distance, whereas electric dipole moments measure the strength of an electric dipole. The third one is provide an example of application of electric dipole used to find the polarity of a system, which is useful in understanding many chemical phenomena such as normal force. So for question B, in water molecule, the oxygen side of the molecule is always somewhat negative and the hydrogen side is always somewhat positive. If the electric potential of positive charge is X and the electric potential of negative charge is Y, propose a formula for the net potential differences and reason to support your proposal. Proposed formula V net equal to X plus Y. The reason is the net potential is the sum of potential associated with each charge, which is positive and negative charge. So the formula is V net equal to V positive plus V negative. So that's all from me. Thank you.
Good morning, my name is Wong and I will present about question 2. Before going to the question 2, I will explain about the formula being used to solve the problem. First, a system consisting of a positive and a negative charge of equal magnetic Q separated by a distance d is called an electric dipole. We can see an electric dipole system in figure A here. Next, to simplify the derivation, we align the dipole along the z-axis and center it at the origin of the figure A electric dipole. For the charge shown in figure A here, the electric potential V towards the observation P is equal to V equal to Q divided by 4 pi epsilon multiplied R2 minus R1 divided by R1 multiply R2. Next, since the D is less than R, the line labeled with R1 and R2 in figure A are approximately parallel to each other, in which case the following approximation apply. R2 minus R1 approximate to D cos theta, and R1 multiply R2 approximate to R square. Hence, V equal to Q multiply D multiply cos theta divided by 4 pi epsilon R square. Previous slide, we already get the equation of electric potential V towards the observation at point P is equal to this equation. Therefore, we can find the electric field by using the formula E equal to negative del multiplied with V, and then we just substitute the V inside this equation, and lastly we will get the equation for the electric field, and we just use the equation for electric field to solve the question 2. So let's start with the question 2. Question 2 is given 10 marks. An electric dipole given the distance vector from positive charge to negative charge is equal to 2 cm. The first charge has an electric field of 8 milliwatt divided by m, which located at r equal to 1 m and theta equal to 0 degree. Find the electric field of second charge, which located at r equal to 2m and theta equal to 90 degree. So let's start with the solution. Since the question given D equal to 0.02 m, E1 equal to 8 milliwatt divided by m, and at R equal to 1 m and theta equal to 0 degree. What is the charge in electric field E1? So we just substitute all the parameter here inside the electric field formula, and then we will find the charge with 0.8 pi epsilon column. So this will get the 5 mark. Next, we can find the electric field E2 at R equal to 2 meter, theta equal to 90 degree, and D equal to 0.02 meter. Since a positive and a negative charge have equal magnitude in an electric dipole, Q equal to 0.8 pi epsilon column. So we just substitute all the parameters here inside the E2 formula, and then lastly we will get the E2 equal to vector delta multiplied 1 over 2 milli V per m. Therefore, the remaining 5 marks will be given for the step to find the E2.
Hi everyone, my name is Firdaus. I'm going to explain how to solve question 3 for our topic. Question 3 states, a square in the xy plane in free space has a point charge of positive q at a corner a over 10 for the x-axis and a over 10 for the y-axis, the same at a corner a over 10, negative a over 10, and a point of negative q at each of the other two corners. So this is the figure for this question. It has two positive charges and two negative charges with their axis. Question 3a has to find the electric potential at any point P along the x-axis. To solve this question, we must know the formula of electric potential due to point of charge is equal to 1 over 4 pi times permittivity, close bracket, times with Q divided with R1. R1 is the distance between the charge with the point given. Back to the figures. It contains of 4 multiple charges. So we must use the summation of the electric potentials formula, which is this one. So let's get through the calculation part to more understand. As I said previously, we use the summation of electric potential formula with two charges to solve this problem. So V equal to Q over 4 pi epsilon naught R1 plus Q over 4 pi epsilon naught R2 plus negative Q over 4 pi epsilon naught R3 plus negative Q over 4 pi epsilon naught R4. So from the figures, we can see that the positive Q charges here is symmetrical with the others positive Q charges. So we can simply say that the magnitude of R1 is equal to the R2. This is also applied to the R3 and R4. So we can put the R1 to the R2 here and the R3 to the R4. So the answer will be Q over 4 pi epsilon naught times with open bracket 2 over R1 minus 2 over R3 close bracket. This is not the last answer because the R1 and R3 is in the magnitude. So we can use the distance vector formula, whereas the R1 equal to square root of x minus a over 10 power of 2 plus 0 minus a over 10 power of 2. This is also applied to the R3. So we can put the R1 into this equation. This also applied to the R3. So R3 also put into this equation. So the answer will be this one after the factorization. Thank you.
I'm Yeong Rachel, and now I will continue for questions 5b, which is evaluate v at x equal to a over 10. At a, we get the r1 equal to square root x minus a over 10 square plus 0 minus a over 10 square, and r3 equal to square root x plus a over 10 square plus 0 minus a over 10 square. So next, we need to sub a over 10 into x. So r1, the answer we get is a over 10, and r3, the answer we get is a square root 5 over 10. At a, we also get the v equal to q equal to 4 pi epsilon 2 over r1 minus 2 over r3. So we also need to sub a over 10 for r1 and a square root 5 over 10 for r3. So this is the solutions, and after that we will get, when simplify all, we will get 5 square root 5 minus 5 over square root 5. So with the calculator, we all get the answer with 2.764. So the final answer is 2.764 Q over pi epsilon A.